Okay, this is the piece that's going to be used for the top plate. And as you can see from the striations on the top, I was in the midst of starting the face milling. And then I had a problem. And well, let's just say that we're going to have to do some other things before we get back to the project. um, it, I guess we'll start at the beginning. We've got a gear on the top of this thing. It's basically a sacrificial gear. Let's take a look here. This is the gear itself right now. Got that unplugged. So this goes on the top of the mill. Let me see where the other part is here. Nope, not over here. Where are we? Oh, here we are. All right. So it mounts on the top of the gearbox on this shaft through this screw. And basically it's designed to break when it gets too much stress. Now what I found out when what the hell they call that? When fly cutting with these machines is that gear breaks. Now a common fix for that is to turn that into a metal gear. And I, after doing a little homework, thought, yeah, that's a good plan. But then I opened things up to see what was inside and realized that if I make that sacrificial gear metal or aluminum or brass, more likely, these ones, namely the high-low transmission gears inside the spindle, are plastic and will break. So I need to make new gears. Unfortunately, I need that gear to make new gears. So I'm going to have to make a cutter to cut gears to fit this tooth pattern. And I'm going to have to make those gears out of metal. These ones. And then I'm hoping I can get a hold of some brass fairly cheaply. And I'll make this one out of brass. And it'll be a sacrificial gear for the metal ones. And that way there my mill will be a lot better off. But that means I've got to switch gears for a couple of days or a couple of weeks here, or at least until I get this all together. So that's led me to a monumental decision about my YouTube channel and my Rumble channel. I think I'm going to start just doing a Sega series of episodes, weekly, bi-weekly, what I'm doing and how things have gone over that week. So keep with me on the ongoing series, and I don't know, sooner or later we ought to end up with something decent going on. Okay, just turned down a piece of square stock because it was the only piece of cold steel I had that was big enough to do that. I'm a millimeter, well, I am 1.02 millimeters off of the outside round. So I'm going to clean that up for you. Hopefully it doesn't vibrate as much as it did before. You know, it's one of those things. Of course, I'm going to flip over the inches because way easier to do 40,000th of an inch. That should be 20. All right, let's see where we're at. According to that, we're at 14 thousandths. So that's where that's at. Let's kick up the speed a bit. There's 4, 8. Yeah, let's go 12 thousandths. See where that leaves us at on a 200 RPM cut. Alright, let's see where that's at. Oh yeah, baby. Oh yeah. So I get that back to where it was. There it is. Well, I don't know about you boys and girls, but I think that's close enough. So that's our outside diameter. Now we need to bring it down to our inner gear diameter, another diameter that we got going on here. Shouldn't take too much. Measure this off. And that's what we're going to go with. That's what I measured. Let's see if we flip that over to there. That's what it looks like on there. It's probably 32.5, but yeah, maybe we'll just make it 32.5 here. Ooh. Problem with reproducing plastic parts is plastic is really weird numbers when you're finished. Never, ever, ever close to what you want them to be. Drives me nuts. So we need to bring that down by 16.4 millimeters or 6.52, which isn't too bad. We're going to mark that off with a marker so we know where to take it to. Somewhere here. Uh-oh, marker dying. Alright. Shut you off for a second. Now we're going to end up going to 652. Should have done this first, but whatever. So, we want that to be like that. Like that. So, we're going to measure the total width. Lock that down. Mark it on here. There's one. And of course we will mark the next one. Next interval anyway. That looks close enough. Uh-oh, that doesn't seem right. Oh, maybe it is. We need more ink. And we'll just double check that. Pretty close. So, those are the only lines we need to continue going on and get her down to our depth. So I'll just set myself up and we'll get going on that. Alright, all set up. We'll just throw that on there, and yeah, there we go, 645 or 648 or whatever it is. Anyway, let's get this going. Alright, alright, you come down. How do you Hey, let's get you wet. What's up, work? Not enough work. Just shoot up. I will be done. You're down to 15. Alright, check this out. Oh, you're down to 224. Should we keep 04? 184. 24, 164. Yeah, we went down. Should be on 64. Let's see what we're at here. Oh, I got 165. Close. 141. 141. Whoa. That should be 101. You're at 102. Bye-bye. 102. 102. Sixty-two. 62. You're at 102. And I'll check that too. I guess it should be a 42, right? We are at 43. Yep, we're at 43. So, take another 20 off. Go with that. Alright, let's check where we're at. I got a sneaky suspicion. What the heck? There we go. Here we go. We got 7 left to go. 7 thousandths of an inch. There's 4. Yeah, that's going to be pretty close to 7. Alright, let's see where we're at that. Should be, oh yeah, 0.5 out. Good enough. Okay, so next thing we got to do is we got to take a break. Alright, we are back and we're going to do a bit of boring in. Of course, we got to make that groove. Better focus in. Oh, there we go. Yeah, there we go. That groove. And for that, we're going to need a measurement. And we're going to need to do some marking. So the first thing we're going to do is we're going to measure the width of that secondary gear there. And oh, we'll turn that on. Alright. Take that measurement. Yeah, that'll work. Whoa. Where did my marker get to? Usually have that here. Well, oh, there it is, right in front of my eyes. There we go. Flip this down to a lower gear because always works better that way. And we will mark it up. There we got that mark. We'll take the diameter. We set that, and off we go to the races. Let's clean up this edge first. I don't know if you can see that on there, but hopefully it comes out. All right, now we go to work. 192. So wait. What up? What up? Give me 100. Oh, let's go. Oh, we should be right now. I'm going to go next. Sorry. And that should be that. Yeah, we're within 1,000 there. I just have one piece that I need to check on that. I will go grab that, bring it right over. Ow. Now this piece is the fork that's supposed to fit in there, and it does not. So we need to check to figure out what the hell's wrong with that. I'm going to do some checking and I will get back to you. Okay, so after checking things out, it turns out that it isn't actually anything to do with any of my measurements. My cutter here, it's got this flux going on in there, and it's bending out. It's caused a slope on there, so I'm gonna have to do some rearranging and get back to you. Alright, I think we got that all fixed up now. Hopefully. That's taking that slope off of there. It wasn't a very big one. It's probably the hardest one to fix. One side down. Oh, sorry, gotta fix the angle on it. There we go. Perfect. And if we look on this one, a little more movement than that. That might jam a little. I'm actually going to take a little bit more off of there. Alright, one more time. Perfect. We got that set. And now I've got to, well, I'm going to see if I can cut it off of here. Oh no, you know what I need to do? I need to cut the shaft. And then, yeah, I'm going to work some things out. I'll get back to you on that one and show you what I'm up to. But I got to put a keyway in. When I do that, I'm going to, well, you'll see. It'll be cool. Okay, I got everything all set up now. And I am ready to bore out my shaft. It's an oddball number, so I'm going to end up boring it out. But for now, this will have to do. It's just under 1/2 inch. It's kind of a weird number for some reason, but it's a friction sort of fit, so we're going with it. Oh no. Always losing that damn key. I'm losing that key. Always the key makes me want to Okay, come on. God damn it. Alright, got it. Where's that coming from? Oil over. Damn it. Where's that fucking shit? Come here. Alright. Come on. Alright, that's what. Okay, so I got that drilled. I got my bore in place, zeroed out, and I am 97 thousandths of an inch off of my bore diameter. So yeah, enjoy the show. We'll bore that out. Huh. Guess we don't get to watch the whole thing. I'll get back to you. Okay, well, it was an eventful evening after the battery died on my phone here. Managed to get this done and carved out. The keyway and that fits beautifully, as you can see. I've already marked it all out for the rest of it. I got to file that all down by hand because still don't have the part for my mill. This is the original gear. As you can see, this is just a beautiful match all the way around. But while I was working on the keyway, I ran into this little problem over here. Let me just move this up a little. Here, we'll take this knob. Oh, lost it. Alright, so over here, damn it. If you'll notice, that's a pretty shiny new bolt. I busted the other one off the bottom, had to make a new one. I've been having nothing but bad luck with this whole machining thing this week. So, hopefully, I can get this all worked out and filed down for you. And, yeah. I'll get back to you once I'm all